We will initially show an empty project, where we selected the Spin Substation Solutions template. After the selection, we will show the project structure that is ready to generate a management application, for a distribution substation, in a few tens of minutes. We select the option to create a new project, and select the number of application tags. In Templates, we choose option 8, Substation Asset Solutions, and create a new project. When the project is opened, we go to the Assets tab, and we see the following. There is the Asset SS, substation that has no bay below. The active topology parameters contain a data structure for the substation topology. There is the Asset XBBS, a dummy variable used to reference all equipment. There is the Z feeder asset, which describes a feeder bay type, with all its variables grouped into 5 collections presented next. Analogs contain the analog variables of the feeder. COM contains the variables associated with the feeder communication relay. Command contains the variables used in the commands. Prot contains the digital variables used in protections, switches, circuit breaks, etc. Top G contains variables to indicate if the lines are energized or not. Finally, the Z line and Z transformer assets describe the line and transformer bay type, with all their points grouped like the feeder. In the Objects folder, we have the object types, Z feeder, Z line, and Z transformer, which define its type when associated with an object name. All the screens, windows, and reports are ready for the application in Draw. For example, we open the alarm summary and show that in the code behind, there is a code in C# that makes it functional. The same example applies to all reports. Next, we open the screen for the single line diagram of the empty substation, which the user will create by copying the bay type objects and pasting them over the screen. The detail screens of the feeder and transformer/line bays are empty screens automatically generated by the application for each bay created. Now let's see the symbol library organized to generate screens of substation bays. In the substation, we have 4 libraries of symbols: base, drafts, bays, and equipment. The base library has all the base symbols used in the bays. For example, we select the symbol of a circuit break and a switch and place them on the screen. We observe that these symbols are the junction of several smaller symbols, already with all the dynamics of their animation. In the draft library, we have the skeletons of the type bays, which are complemented by the base library symbols. For example, we took the draft of a feeder and filled it with a circuit break, a ground switch, and a feeder switch. In the bays library, we have 2 types of application bays, the feeder and the line/transformer. We put the feeder bay on the screen. And, for example, we run the unmake symbol command, which decomposes it into dozens of smaller symbols. Finally, the equipment library has mirrors of the IEDs used in the system architecture screen. Going to run, extensions are shown only a few extensions, which are routines developed in C# and executed at design time. Of these, we highlight two. The topology generator extension is used to make the adjacent matrix associated with the topological processor. The deploy extension generates all alarms, event history, and the points of each new bay created. Let's close this application and open the demo application shown earlier. In this application, to show the simplicity of creating a bay, let's add a third feeder bay, and then let's run the demo. When opening the demo application, in the Assets tab, we have 5 bays in Asset SS, 2 feeders, a 13.8 kV bar, a 69 kV line, and a transformer. In the Objects tab, 5 objects represent the 5 bays, each with its bay type. To create a new feeder, we copy the line from the 21S2 feeder, and paste it on a new line, and we are going to replace the text S2 by S3 in all the fields where this text appears. Go to the Channel tab and create a new channel, 21S3R. In Protocol Options, we copy the text from channel 21S2 and paste it into channel 21S3, changing S2 by S3. You go to the Nodes tab and create node 21 SAR. We go to Run, Extension, and run the extension topology generator. In the open window, we select the display of the single line diagram and the operator level SS. In the adjacency matrix, we put a V in the row of bus 13, and column 21S3, and save the modified matrix. We run the deploy extension, select alarms, historian, and points, and press the Create button. Deploy will create all alarms, historians, and points of the newly created bay, 21S3. After executing the extension deploy, on the Historian tab, we can see that records were created for recording the history of feeder 21S3. Going to Alarms, on the Items tab, registers were created to generate alarms for bay 21S3. And finally, in Devices, in the Points tab, the points with the addresses IEC 61850 of feeder 21S3 were created. The next step is to add the new feeder bay to the substation single line diagram screen. Go to Tags, select the Objects tab. Copy the line with the object name spin S123, and return to the Unifiler screen and paste it. Next, we adjust the position of the new feeder bay and save the screen. The demo application is ready, the new 21S3 feeder has been added, and let's run it to see if everything is okay. In our simulator, there are already 3 simulated feeders. Go to Run, Start Up, and activate Demo. The demo automatically connects to the simulator. And if we command circuit break, it opens, de-energizing the feeder, as shown. If we navigate to the feeder 21S3 detail screen, and see that the screen was created automatically, without any configuration effort. We lock and unlock feeder 21S3, and it works okay. Finally, we open the transformer low circuit break and see that the topological processor is working, de-energizing the 13.8 kV bus and the 3 feeders. With that, we conclude this presentation. In a few minutes, we create a new feeder bay, with all its points and screens, and integrate it into the application.